All right. One of the questions I received was to. This was from your Chapter 9 quiz that I think is due on Friday, or was it today? Friday. This is one of the questions where you use chain rule, and remember I said the notation's always the tricky one. And you got to understand it's the inside. You derive the inside function using chain rule, and then you derive the outside function. So I'm just going to write down the rule again so you remember. So this was the chain rule. If the function was like that, okay, this is called the inside function, okay? And when you find the derivative or the chain rule says you are going to find the derivative of the inside, which is what I've highlighted, which is the derivative of g of x times the outside function, which I'm going to use a different color, and it's f with g of x inside of it, but you find the derivative. So this is what I'm going to write. I'm going to write f dash, which is the derivative of g of x inside. So how does that relate to our problem? Well, our problem currently is y equals 2 f 2 times f of x all to the power of 4. So similarly, you can also say that the inside derivative, so if we want to find g dash of x, must be finding the derivative of this. Now, derivative of f dash, I don't know what it is, so I'm just going to write f dash of x, because that's the derivative. But remember, whatever the derivative, you're going to times it by 2. Okay? So I'm going to write here, this is dy dx. Oh, whoops, I should write that so you can see the difference. Okay? So, if this is the derivative, so far I've only got g dash of x. I need to find now the derivative for f dash of the function. Now, if you think about the function, ignore this inside, ignore that, and just pretend you've actually got one whole function to the power of 4. You see what I'm saying there? Like, this is technically, if you ignore what's inside, you actually just got something to the power of 4. That's what you have, yeah? So if I asked you to find the derivative of this, you would say the derivative is equal to 4x to the power of 3. True? Using power rule. Now, it wouldn't be any different. The only difference now is instead of x, it is the whatever you call the inside function as, and in this case, because you don't know what the inside is, the derivative would still be 4 times, and instead of x, see, I replace 2f of x as x, then it's still 2f of x to power 3. Do you see what I'm trying to say there? All I did was I replace this x with this, yeah? And I said to find the derivative was just this. So I wrote exactly that. I got a 4. I got a 4. I've got x, which is this. I've got cubed. You see, it's just a notation. It's like, it looks hard, but it's not. So if I write it out, it's actually 2 times f dash of x times 4, bracket 2f of x all cubed. True? Now, in terms of numbers, 2 times 4 is actually 8. And then you got times f dash of x times 2f of x all cubed. Now, here's the interesting thing. If I look at the answers, none of the answers give me what I'm looking for. Okay, so this is as close as it gets to my answer. But why do they have a 64 and I have an 8? Well, what they did was they manipulated the inside. So if you have a look here, I'm just going to manipulate here. So this is the inside. Remember, you're cubing it. So technically, you can actually write it as 2 cubed times f cubed of x. You see, all I did was cube the 2 and cube the f of x. So if you write it out again now, all I did was I've expanded the brackets, okay? Because they're being multiplied, it's okay to change the powers of each. It's like saying this. If I gave you AB all cubed. That's the same thing as writing a cubed, b cubed. True? Well, instead of ab, I now have 2n f of x. So it's the same thing. You just write 2 cubed, and technically it's f of x all cubed. Alright? And 2 cubed we know is 8, and that's times with the 8 as well. That's why they got 64 times f dash of x times, and technically that's just f of x cubed. That's why the answer is D. Okay? I hope that makes sense. Again, just it's the notation. It's not the technique, because if I had changed all the notation and you used A, B, I'm sure you guys would have been able to do it. It's just because of the notation, which is why I'm saying year 12, you got to learn to be able to read the notation as if it's your A, B's and X and Y's, you know, like why is this easy and yet this is hard? You know, technically they're the same thing. But anyways, that's the answer. So rewatch this if you need to. But that's I can't remember which question it was. It's probably question 6 of your chapter 9 derivatives. Okay. Thank you.